A very warm welcome all of you to a new video. Hope all of you are fine, doing well, right? So let's start with a new video. And in the previous video we have had the discussion on what are the rationals and irrational numbers, along with how can we represent the real numbers altogether in the number line. Now the topic is basically the real numbers and their decimal expansions, right? So decimal expansions mean basically we can express any rational number or irrational numbers in the form of decimals. So decimals means what? Decimals means, so now we are going to express all the real numbers in the decimals form. So if we see here, let's take three examples of real numbers. One is 10 by 3, second one is 7 by 8, and the third one is 1 by 7. As we can see here that 10 by 3, 7 by 8 and 1 by 7, we can express these numbers in decimal form. If we divide, here we know that 10 is divided by 3 means 10 is the dividend and 3 is the divisor. So 10 by 3 is basically represented in the form of this. 3 3s are 9, 3 3s are 9. By putting this, by subtracting this one, we get 1. And after putting the decimal, we can have infinite number of zeros from here, right? So we can bring 1 0 down to here. Then 10, again 3 3s are 9, again 1, again 1 0 comes down, again 0 comes down, like this. It stays, or it is basically infinitely many numbers of 3 can get repeated here. So basically after doing this, we can conclude that 10 by 3 is equal 3.333. It continues, right? And then the next example, if we see here, next example it is 7 upon 8. So 7 is the dividend here and 8 is the divisor here. So 8 0 is 0, and putting that, again we got 7. After putting decimal, we can have infinite number of zeros in the right hand side. So it got 70. So 8 is 64 minus kale, 6 0, again 0 putting down here, 8 7 is 56, right? By subtracting here, we get 4 again 0 as 40. So 8 5 is 40. Now is so decimal expansions. Previous classes, class 7 and 8, 6 and 7 already we have had. So it is normal division process that 7 by 8 is equal 0.875. So first of all, let's have all the examples, then we can conclude whatever we are finding. Now we have 1 upon 7. So 1 is the divisor here and 1 is the dividend here and 7 is the divisor here. So 7 0 is 0. By putting this, you can have, after the decimal point, you can have 0. We have got 10. 7 1 is 7. By subtracting it, 3 0, 7 4 is 28, minus again 2 0, 7 2 is 14, again 6 0 7 8 is 56, again minus kalapare, we get 4 4 0. So empty side to it is infinite number of zeros we can have, right? From this you can take, or you can bring zeros to the below the table, right? Empty 0 0 and infinitely number of zeros, infinitely many number of zeros can brought back to the down. So in the elaborate, we got that 7 1 upon 7 is 0. This is 1 upon 7 is 0.142857 continues, right? So by doing this, what did we get here? We got that whenever the remainders are 1, the remainder 1 rolls, right? In all the cases, we are finding the divisor as 3, right? Whenever the divisor is 3, we are finding the remainder we get, that is 1. If the divisor 3 achi, ame remainder pauche 1. If the divisor 8 achi, we can get remainder what? So in all these cases, you get 1 1 and 1 as the remainder. Whenever the divisor is 8, you get how much? You get 6, 4 and 0. So whenever the divisor is 8, you get remainders as 6, 4 and 0. You remember this. Both questions this could be repeated, right? Whenever the divisor is 3, we get the remainder as 1, 1 and 1. Whenever the divisor is 8 here, we got the remainder as 6, 4 and 0. Whenever the divisor was 7, we got remainders as what? First we got 3, then 2, then 6, then 4, then 5, then 1. First 3, 2, 6, 4, 5, 1. Again you can get that 3, 2, 6, 4, 5, 1. If you continue doing that, then you could get these numbers again and again and again. Many times you do. As many times you do, you will get the same things repeatedly, right? Now, so what have we noticed here? What did we get from here? You have noticed, or we have noticed, that the three things here, at least, the remainders either becomes 0 after a certain stage or start replacing themselves. Remainder kichi case 0 he jauchi, nale author repeat koruchi, right? This is the first thing. And the number of entries in the repeating string of remainders is less than the divisor, right? Basically, the number of entries in the repeating string, jitole repeat hoji kichi jinsa, right, is basically less than the divisor. For example, 10 by 3, one number repeats itself after that, and the divisor is 3, right? And if we see here, second point says that the number of entries in the repeating string, it kete repeat hoji? 0.142857, 1.142857 empty repeat hoji. So it divisor kete 7 tharu ei number of digits ta jeti ki repeat hoji seta sabala kam. Here we have got 1 2 3 4 5 6 entries in the repeating string. Repeating string mane jetla repeat hoji, right? If we see here this is 0.142857, 142,857. This is 1 by 7, right? And another one was there, 10 by 3. This was like this, 3.33333. This was getting repeated, right? So the second point we noticed here, that the divisor, this is the divisor, this is also the divisor. Here the divisor is 7, and the number of entries in the repeating string re ketna digit ache? It is 6 digits. So 7 is always greater than 6. It kete ache divisor? 3, right? And the number of entries in the repeating string re ketna digit ache? Gote digit pore hi repeat hochi. So 3 is always greater than 1. So jinsa ta id I conclude kale, right? And the third point we have noticed here, if the remainders repeat, then we get a repeating block of digits in the quotient. If the remainders repeat, then we get a repeating block of digits in the quotient. Quotient we get a repeating block of digits. So the third point says us that if the remainders repeat, right? Jemti ki eti hame dekhile ki 10 divided by 3, what do we get? 3 3 is a 9, we get 1, after putting point here we get 0, 3 3 is a 9, again 1. So remainder eti 1 pile again what bachu? So repeat hoji na, repeat hele eti repeating block ra amku digits miliyala. This is the third point we have noticed here, right? Okay. So finally we can conclude here, I am empty conclude kar pariba. The remainder becomes 0 or never becomes 0, and we get a repeating string of remainders. So jetale remainder 0 he jauchi, remainder jetale whenever the remainder becomes 0, right, setebale ame dekhuche gote case hochi, right? The remainder becomes 0, and that can never become 0. So remainder sometimes never become 0. So whenever the remainder never becomes 0, we get a repeating string of remainders. So dita case हम पाखे रहा, गोटे केस रे रिमाइंडर कौन होची 0 हो जाउची, आ गोटे केस रे रिमाइंडर बिल्कुल 0 हो नहीं, right? So whenever the remainder is becoming 0, then we say, right, or we call those decimal expansions of such numbers as terminating decimal expansions, right? जितेबाला रिमाइंडर टा 0 हो जाए वी कॉल इट एज द टर्मिनेटिंग डेसिमल एक्सपांशंस राइट जमती आम देखिले 7/8 सो 7/8 रे by 7/8 इज इक्वल 0.875 सो टर्मिनेटिंग मीन्स जोटा को आम काउंट कले नंबर सिस्टम रे एंड हुए right so here we get here we get what we get 0.875 that means number of digits after the decimal is terminating means that is ending right after you count then the number system the end of number system appears there that means tame limited number of digits decimal point pare pauch count kari haba jo right countable number of digits we get so that is terminating decimal expansion very simple whenever the remainder becomes 0 जेतबे remainder 0 हो जाए हम terminating decimal expansions को second case को the remainder never becomes 0 second example हो the remainder never becomes 0 in those cases like 10/3 1/7 so the remainder के भी 0 ही होनो थला so if the remainder was never getting if the remainder was not never becoming 0 then that kind of decimal expansions are basically known as non-terminating decimal expansion. So, acha you leave this recurring phase, right? Recurring ta chada usually non-terminating decimal expansions ko house, right? For example, 10/3, 1/7, right? And one more thing is there, right? We are going to discuss now. So, आम फर्स्ट देखिले कि किछटा टर्मिनेटिंग डेसिमल एक्सपांशंस थिला और किछटा नॉन टर्मिनेटिंग डेसिमल एक्सपांशंस थिला राइट सो टर्मिनेटिंग डेसिमल एक्सपांशंस रे आम देखिले कि टर्मिनेटिंग डेसिमल एक्सपांशन माने आफ्टर द डेसिमल राइट आफ्टर द डेसिमल राइट जेमति कि मु 3.567 लिखली कि 2.57 लिखली कि 7.05 लिखली व्हाटएवर आई राइट so these decimal expansions are terminating decimal expansions while these numbers while I say you while I represent any number like 7.52932 ellipsis points and the continuous points to the these are basically non terminating decimal expansions so ebe one more thing I want to summarize here I would summarize kariya chahanchi कि टर्मिनेटिंग डेसिमल एक्सपांशंस दी टाइप रे अछंती नॉन टर्मिनेटिंग डेसिमल एक्सपांशंस भी दी टाइप रे अछंती वन इज टर्मिनेटिंग रे भी रिकरिंग अछंती नॉन रिकरिंग भी अछंती सो टर्मिनेटिंग रे रिकरिंग डेसिमल एक्सपांशंस किए अच्छा लेट्स सी हियर कि 3.757575 एंड दैट्स और विच इज 4.7272 right this much so these are terminating decimal expansions and also these are repeating decimal expansions that means after the decimal point the digits right the string of the digits are repeating themselves so repeat ho jandi that's why these are terminating recurring decimal expansions and terminating non recurring decimal expansions let's have a look on them jemti ki dekhu je terminating 0.725 it kichi repeat hona no string of digits is getting repeated here kehi bhi repeat hona so this is non terminating non recurring that means non repeating right so now the fact is the summarization comes to the play here that terminating decimal expansion non terminating decimal expansions or recurring terminating recurring terminating non recurring non terminating recurring non terminating non recurring so this concept is basically based upon a different point of view to look from a different point of view if we are looking towards the rational and irrational numbers ये whole concept होउची कि rational और irrational number को आमे केमती अलगा point of view रो देखुचे from the point of view of their decimal expansions so rational और irrational को आमे already we know that any number which can be represented in the form of p by q that is a rational number right and any number which cannot be represented in the form of p by q that is an irrational number but ये जो decimal expansion point of view रो देखुचे कि decimal expansion हिसाब रे को number टा rational को number टा irrational से जिनसटा टिके डिस्कस करिया right okay so first असला terminating recurring numbers terminating recurring decimal expansions को हम जितना देखुचे 2.7575 let's say easily we can represent or we can express this expansion in the form of p by q like this would be equal to 27575 upon 10000 हेगला p by q form रे p by q form रे हेगला. So this is a rational number, we got to know that, right? And terminating non-recurring, so terminating hela mane we got the liberty of expressing the number into p by q form. Terminating non-recurring, for example I say you 3.729, simple. So this can also be get represented in the form of p by q 3729 by 1000. So p by q form rahela. So this is also a rational number, right? And now the fact is कि non-terminating numbers jete sab asile, so we do not know how many digits are there after the decimal. Let's say mu कहली 1.72592 dot 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 एमती दिया है, right? So कथा होजी कि एठी हमें जानिने, we do not know how many digits are here present after the decimal, so we can never write it in the form of p by q. हमें केबे भी लिखि परिबे ना, because we do not know how many digits are there after the decimal. Since we do not know, that's why we cannot put the same or equal number of zeros after 1 in the place of denominator. हमें एटी जानिने, जेहेतु हमें जानिने जे केतेटा डिजिट अछंती डेसिमल परे, सो हमें p by q फॉर्म रे को केबे भी लिखि परिबेनी, राइट? दिस इज ट्रू? नो, दिस इज नॉट ट्रू फॉर बोथ द केसेस. दीटा जगह केस पे एटा ट्रू नुहे. सो नॉन टर्मिनेटिंग नंबर्स माने जदी रिकरिंग होचंती, देन वी कैन represent them in the form of p by q. That means they are rationals. We'll see how to convert them, how to represent them. But non-terminating, non-recurring numbers are sheer irrational numbers. So these are irrational numbers. केमती ना, simple जिनसा non-terminating, non-recurring. So हमें जानने how many digits are going to be present there after the decimal point. That's why these are irrational numbers, right? We can never represent these non-terminating, non-recurring numbers in the form of p by q, right? But one doubt was basically arising there, that how can we represent the non-terminating recurring numbers in the form of p by q, because we do not know. So simple जिनसा होची कि हमको 3.75 given है, 3.75 को सॉरी 3.757575 एमती अछि. सो आपको केमती p by q फॉर्म रे रिप्रेजेंट कर परिया, राइट? इटा पूर्वरु लेट्स हैव अ लुक ऑन द होल फ्लो चार्ट. ई फ्लो चार्ट को हमको ई फ्लो चार्ट देखि कोन जान छै ना, जते सब टर्मिनेटिंग डेसिमल एक्सपेंशंस अछि से रिकरिंग हो कि नॉन रिकरिंग हो. So ये होची rational numbers, and here these are also rationals, right? Rational numbers. हमें जिम्ति कि आज we were discussing that non-terminating, non-recurring numbers are irrationals, right? These are sheer irrational numbers. ये गुड़ा ही होची से irrational numbers, right? But गुटे doubt was there that how can non-terminating recurring numbers are called rational? How can these numbers or expansions can be called as rational numbers? Let's learn this. Agute learn kariya, right? Okay, so let's see one more time. I am repeating the flow chart. Concept होची या कि पूरा whole summarize करके से concept होची कि जते terminating recurring decimal expansions are rational numbers. Terminating non-recurring numbers are also rational numbers. Non-terminating recurring numbers are rational numbers, but non-terminating non-recurring numbers are irrational numbers. That is it. Now we are going to learn. अच्छा, इधर तो बहुत easily है ना. Non-terminating recurring numbers are rational. Easily जो p by q form रे इटा भी जो. But इटा गोटे हमरा doubt रोतला. How can we solve? How can we do or convert or express the non-terminating recurring numbers into rational form or p by q form? Let's learn this. Assume that there is a number which with the decimal expansion having 3.7575. This is a non-terminating decimal expansion, and always this is a repeating or recurring decimal expansion. So before going into the action, we must know that how should we write the recurring numbers. Recurring numbers को केमती लिखिया. So if this is 3.757575, one more thing, how many digits are there in the repeating string here? जो रिपीटिंग स्ट्रिंग अच्छी कितना डिजिट अच्छी से बेसिकली देर आर 2 डिजिट्स कि 7 and 5. After 7 and 5 also we are getting same 7 and 5, 7 and 5. So repeating string we have got only 7 and 5 which are after the decimal point. So 3.75 is the number here. But what do we get here? We get that 7 5 is getting repeated, right? So 7 and 5 data digit are there in the repeating string. Is repeating string को we represent this as a bar, right? So we represent this as a bar. इटा को repeating string कहते. So anyway, if I write for example some more examples we are taking here to understand to have the understanding to make the understanding better. Let's say 0.7777. So this point should this ellipsis points or this continuous point should be replaced by this string, the bar. So it could be written as 0.7 bar. Clear? Let's say 2.505050, right? So this could be written as 2.50 bar. So this is the repeating string. It repeat we put a bar on them, right? You must be wondering that mind a question asked to sir, how many times we are going to repeat these repeating strings at these digits? Basically after whenever you write these in the expanded form, the expanded form you can maximum you can repeat up to 3 places, right? 3 times tame repeat kariwa, then you put the decimal, you put the ellipses or continuous points. 3 thara emti repeat kala pare point de dele, okay. If you are writing in this form, just a form otherwise you write this directly. This would be the very easiest, very easier or more easier than this, right? Okay, so let's have it. How can we convert the decimal expansions into this non-terminating? This is non-terminating. Once again, this is non-terminating, right? This is non-terminating. Sir, this is non-terminating. Yes, also this is non-terminating, also recurring. Yes, so this is a non-terminating and recurring decimal expansion. As we have said, as we have discussed in the flow chart above earlier, that non-terminating recurring numbers decimal expansions are rationals. This is the most confusing thing. This is a confusing thing. Kimti ame likhiwa to janine how many digits are going to be repeated here. So rational number means p by q form रे हमें represent कर परिया, obviously for sure p by q form रे जदि represent करिया, so there would be a numerator, right? A numerator should be there and a denominator also should be there. So एमती assume कर परजो 3.757575 को first of all हमें एमती लिख परिया 3.75. So what are you assuming here कि numerator, what could be the numerator? Numerator 375 हवा भाभी पढ़ो. Okay, you can ask sir, how can we calculate the exact number of zeros after the 1 in the denominator place? Can it be or could it be 2 zeros, or because it is never ending na, so कितना zero? So can we put dot continuous points here? No sir, this is wrong, right? This is not the right method to do this. Let's learn how to convert, how to express any non-terminating recurring decimal expansions in the form of p by q. Let's have it. Okay, so the question would be like this: express (3.757575) in the form of p by q, right? If this is the question, obviously this would be the question, right? Let's have the answer, let's have the solution. So solution would be like this. First of all, we must assume, let's assume that x is equal to 3.757575. This, as we know that just टिके आगुरु आम एमती लिखुले आगु एमती भी लिख परिबा. We learned that that x is equal to 3.75 bar. एमती बार लिख परियो because repeating string रे 75 अछि clear. So that x is equal to 3.75. Assume करियो कि 3.75 होची x. Okay. So if x is equal to 3.75, now you tell me if I multiply 10 in the left hand side of the equation, this is the equation, this is an equation here. So if I multiply 10 in the left hand side, what it would be? 3.757575 we multiply over 10. So if we multiply 10, that means 1 0 is there. So after you multiply 10, 100, 1000, whenever you multiply these such numbers with decimal expansions, then the decimal would move or jump towards right. How many places? As many number of zeros are there in the 100 or 10 or 1000. जितकी मल्टीप्लाई करियो सेतिरे केतरे जीरो अछि इतरे 1 0 अछि सो गोटे प्लेस जंप करियो. So what it would become? It would become like this 37.575757, isn't it? 37.575757 continuous. और केमती लिख परियो हम सब रेफरेंस टा दे देछ और एमती ही परियो कि 10x is equal how much? 37.57 bar. Clear? Okay. So you would ask me, sir, you should have been asking me, or you would ask me, there would be a doubt in your mind that, sir, why we are multiplying 10 or whatever in the equation in both the sides? Because we need to have exactly the same decimal places or decimal digits, right, in these numbers. Then what would happen? We see that tapare dekhiya. So unless and until we get the equal number of what, equal or same number of expansions after the decimal, till then we should continue doing multiplying or multiplication. Now you keep increasing the number of zeros. 100x again 10x if jodi etik hochi, then 100x means out one more zero multiply, so this would be 375.7575 and 75 . Clear? Or it empty haba na, or 100x is equal 375.75, right? Surely एबे देखो हमको गोटे आइडिया मिलगला, right? What idea did we get from here? We got the idea, right? कि देखो इठी डेसिमल परे सेम जिनस 757575 एठी तो इक्वल नथिला, एडी भी we are getting the same thing 757575. So you mark this equation as equation 1 and the same equation, right? जे पर्यंत सेम नंबर जे से पर्यंत हम मल्टीप्लाई जीरो इंक्रीज करी करी जाते. We got equation 1 and equation 2, right? Next, so if we count kariya, the trick is to subtract the equation 1 from equation 2. We can write here, so subtracting equation 1 from equation 2, we get, what do we get here? Simply what is the equation 2? 100x minus this is here we get x. Equation 1 the left hand side x is simple. Left hand side of the equation 2 and left hand side of equation 1. This is x, this is 100x minus x would be equal to right hand side of equation 2 375.75 bar minus 3.75 bar. So what it would be? 100x minus x will be 99x is equal, acha one more thing, 375.75 bar and minus 3.75 bar, the same things are here. So 75 bar would be cancelled, so you get 0 here, so 0.0. So 375 minus 3 is 372.0, so which is equal to 372 only, right? You leave this was for the rough purpose, it a rough fine thila, you leave that. So So 99x will be 375.75 bar minus 3.75 bar. It would be 372. So x will be 372 upon 99, right? Is it clear or not? Okay. Now we can cancel out these things, right? We can simplify these things a bit, right? So simplify collaborate, we would get what again if you cancel out, sorry, yeah, we can cancel out, this is getting erased. So 372, so 3 1s are 3, again 3 2s are 6, 1 2 3 4s are 12 upon 3 3 3 3, right? So this is the final answer, right? This is the solution. Now we can say that, right? What we can say, what we can assume here, we can assume here that therefore 3.757575 ... is equal 12433. Got it? So this is the final answer. And here a terminating, recurring decimal expansion, sorry, this is a non-terminating decimal expansions. For your correction, this is a non-terminating decimal expansion, and this was a recurring decimal expansion also. Non-terminating, recurring decimal expansions can be represented in the form of P by Q. So these are loudly correctly we can say that these are rational numbers, right? Or these belong to the set of Q, right? This is it about this. Now we are moving towards the example number 6. So that 3.142678 is a rational number. In other words, express this number in the form of P by Q. Simply, as we know, this is a terminating decimal expansion, right? This is a terminating decimal expansion, so that we can represent it in the form of what? In the form of P by Q. Simply 3142678 by 1 2 3 4 5 6 zeros, 1 million, right? Done. And recently we learned how to represent 0.3333. that means 0.3 bar can be expressed in the form of P by Q, where P and Q are integers. So basically we got to know the process, right? Since we do not know what is 0.3 bar, let us take it as x. So same method recently, just a little while ago, I was doing that same method solve kar de paribo, and after that you would get 0.3 bar would be equal to how much? 1 by 3, right? This is it. And let's move to the next example, example number 8. So that 1.27, similar method, similar question, so similar answer would be there, which would be x will be equal to 14 by 11, right? That means 1.27 will be equal to 1.27 bar is equal to 14 by 11. Now another question is there, 0.2353535 is there. Take a tricky here, directly sabujaka every digit after the decimal is not under the repeating string. So bar under the bar, no, not all the digits are there. Sabujaka digit bar re nahi. So it is tricky, but you can achieve that, you can do that very easily. The only fundamental thing you have to remember, the basic thing you have to remember, ki unless and until we get the same set of bunch of digits after the decimal, se parjanta you keep on multiplying. Je parjanta decimal pore, this is x, right? We know that x is equal to 0.235, 35 upare bar. So directly ame eti 100x kale, 100x ro we get 100x means edi padegala. So 23.53, right? 23.535353 chala, because 2 repeat havani, 2 1 only once. 100x is equal to this, right? Therefore, acha it is directly alga method re karchi, 99x negi karchi, no problem, 100x rate ko plus kariki, but I am a similar method re kar pariba. I am jo method re shikle, easily we can do that, right? Okay. Let's move to the conclusion that we get from here. The decimal expansion of a rational number is either terminating, non-terminating, recurring. Moreover, a number whose decimal expansion is terminating or non-terminating, recurring is rational. I made a general. So So what are irrational numbers? Irrational number is non-terminating, non-recurring numbers. So the decimal expansions of an irrational number is non-terminating, non-recurring. So irrational number decimal expansions are non-terminating or non-recurring. Moreover, a number whose decimal expansion is non-terminating, non-recurring, that is irrational, right? I hope you got it. Jemtiki root 2, right? So root 2 is an irrational number. The root 2 will be decimal expansion. You get 1.41421356237309 unless and until we are going, you can achieve, you can admire here that you can observe here that root 2 or the decimal expansions of root 2 and pi, here the digits are not getting repeated. Repeat hi hounandi as much as you can, jama hi repeat hounandi. So obviously this is a non-terminating, non-recurring, right? Non-terminating, non-recurring. So pi भी सही है 3.145926 एमती चलते non-terminating, non-recurring. So note that we often take 22/7 as the approximate value for pi, but pi is not equal to 22/7 because हम तो देखो ना pi रे decimal expansion is this one, but 22/7 whenever we write 22/7, so it's in the form of p/q as we know, but contradiction is. So here is a contradictory thing. This is, how can we say that pi is an irrational number? Because pi is the decimal expansion of pi is non-terminating, non-recurring, but we are representing pi as 22/7. That is why we, for our convenience, for the convenience of the calculation in the mathematics, we take the pi as 22/7, but pi is not equal to 22/7. You must remember that, right? Okay, let's have a historical discussion on the discovery or invention of these irrational numbers. So as we know, in the Sulabha Sutras, the rules of chord, a mathematical treatise of the Vedic period 800 BC to 500 BC, you find an approximation of root 2. केमती root 2 रा value को Vedic mathematics रे एमती express कराया था 1.4142156. This seems to be a terminating decimal expansion, but actually this is not, right? Because root 2 is an irrational number. So let's have the history, a bit of history discussion. The Greek genius Archimedes was the first to compute the digits in decimal expansion of pi. Pi ra decimal expansion ra calculation or computation first time pi history, in the history of the mathematics, the Greek genius Archimedes was had done that, and he showed that 3.140845 and 3.142857, the value of pi lies in between these two. 3.140845 और 3.142857 भितर ही पाई रो वैल्यू पड़ुची. आमर चलो आम ग्रेट इंडियन मैथमेटिशियन आर्यभट्ट कथा देखिए जी कि 476 BC रे बर्न, सॉरी कॉमन एरा CE रे बर्न एंड 550 रे डेथ तांकर. द ग्रेट इंडियन मैथमेटिशियन एंड एस्ट्रोनॉमर फाउंड द वैल्यू ऑफ पाई करेक्ट टू 4 डेसिमल प्लेसेस. आर्यभट्ट कौन करते जो 4 डेसिमल प्लेसेस पर्यंत पाई रो वैल्यूटा को डिफाइन करते. बट एबे हाई स्पीड कंप्यूटर्स और एडवांस्ड एल्गोरिथम यूज करिकी पाई रो जो वैल्यूटा बा पाई रो डेसिमल एक्सपांसनटा इट हैज टू बी 1.24 ट्रिलियन डेसिमल प्लेसेस. दैट मीन्स आफ्टर द पॉइंट पाई इज हाउ मच 3.142857 एमती करी 1.24 ट्रिलियन प्लेसेस पर्यंत वी हैव कंप्यूटेड हमें कैलकुलेट करछे, बट स्टिल रिपीट हो नहीं, राइट? 1.24 ट्रिलियन, ट्रिलियन मीन्स 12 zeros अच्छी तरह. सो इतनी नंबर ऑफ डेसिमल प्लेसेस पर्यंत बाहर कला पर भी हो. Example 10, find an irrational number between 1/7 and 2/7. As we can see, 1/7 रो decimal expansions have 0.142857, right? As we can see, 1/7 रो decimal expansion is 0.142857, and this is repeating string रे रहे. And 2/7 is 0.285714. I को normal division method रे हमें कर परिया, right? So here आमुक वाइज the answer should be right. The question which has been asked to us that we have to find out an irrational number between 1/7 and 2/7. So irrational number should be non-terminating, non-recurring. So I am देखिए कि that irrational number should lie between 857 bar and 0.285714, right? Ankara bar. So तो आंक भितर गोटे डिजिट आमको एमती मिल पार जे ये देख सिंपली 1 4 दिस इज 2 8 दैट मीन्स 1 4 पर जहाँ भी कले एंड 2 8 भितर हवा दरकार 14 एंड 28 भितर को भी नंबर यू चूज 0.15 तापर मन इच्छा राइट एज यू कैन जेमती रैंडमली पुट द डिजिट 001 2 003 44 45 4 9 2 7 dot 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 right empty infinitely many irrational numbers you can find out between two rational numbers. Dita rational number with we can find infinitely many irrational numbers. So along with this is the completion of I marked the completion of this concept here, and by learning this you can complete the exercise 1.3, and in the next video we are going to learn how to solve the or how to operate between different real numbers, right? So the operation of real numbers will be discussed in the next class, right? Now okay, let's wind it up. It's been a long video, so have patience. Any doubts if you would have, then let me know in the comments. Thank you and see you, right?